This simple push button connects the pins on the left with the pins on the right when pressed. It's so simple, it is frustrating how often inputs on an Arduino seem completely random when using one. This tutorial will explain why that occurs and how to fix it without adding any extra hardware. The hardware used in this tutorial will be a push button, breadboard, and Arduino. One side of the push button will be connected to 5 volts, while the other side is connected to the Arduino's pin 12. For completeness, the Arduino's 5 volts and ground will also be connected to the breadboard rails. Now that this is complete, USB is attached for power and to upload the code, which we'll do next. As with any good source code, the first thing added will be a brief description of the project in a comments section. In the setup section of the sketch, pin 13 is configured as an output to make use of the Arduino's built-in LED. The push button is connected to pin 12, so it is configured as an input. The sketch's loop will use a variable to store the state of pin 12 and then set pin 13 to that value. This means the LED should always show the state of the push button. After the code is verified, it is uploaded to the board. The first time the button is pressed, the LED is turned on as expected. However, nothing seems to be able to turn it off. Just hovering a finger around the button will cause the LED to start flickering, which means the LED is reacting anytime the finger is near the push button. Even stranger, touching the in-circuit programming header gets a reaction. In fact, it is even more responsive than the actual push button. If you wait long enough, the LED will just shut itself off. Just what the heck is going on here? Well, the problem can actually be seen in the schematic. On the left of the button is the 5 volts and on the right is pin 12. What is happening is when the switch is not pressed down, pin 12 is unconnected to anything. So any electrical noise in the air will cause the value of the digital read to randomly change. This is called floating. The oscilloscope is connected to pin 12. When the push button is pressed, the trace on the screen moves up and then falls back down. When the finger is touching a pin or any metal near the pin, a voltage is coupled into the signal, and is why the value is randomly changing. So now that we know what the problem is, how do we fix it? Well, it is pretty simple. Here is a schematic of a push button with a couple of changes. On the left, the button is now connected to ground. The right of the push button is still connected to pin 12, but now is also connected to 5 volts through a 10K resistor. This resistor is called a pull-up resistor. Now when the push button is untouched, the value of pin 12 will be pulled up to 5 volts. When the button is pressed down, this will connect ground to pin 12, allowing pin 12 to read 0 volts. In order for the breadboard to match the new schematic, a single change needs to be made in hardware. Simply change one side of the button from 5 volts to ground. The digital write command is usually only used for outputs, but when a high is written to an input, it actually turns on the internal pull-up resistors of the pin built into the ATmega chip. With the changes made to the breadboard and this single line of code, the circuit matches this schematic without any additional hardware. After this final upload, the circuit should respond better. One of the changes now is that the default state of the light is on when the button is unpressed and off when pressed. It doesn't matter where the finger is placed on the breadboard, the Arduino can't be fooled this time. The oscilloscope will show a very nice clean transition from 5 volts to ground because there's no more noise. Next time you're using buttons or switches on your project, make sure you use the internal pull-up resistors to keep your inputs from floating. If you have any questions, feel free to leave them in the comments below or visit www.cmiyc.com.